Machine learning models are used everywhere today. We trust them to make decisions. We say everywhere, we really mean everywhere. From single things like filtering emails to serious systems like medical tools or financial systems. Machine learning models are constantly making choices in the background. Over time, we are getting used to trusting these decisions without thinking too much about them. These decisions affect real people and real system. This means the output of model does not stay inside a computer, it moves into a real world. A prediction can influence what action is taken next, who gets the access to service, or what kind of decision is made for a person. The problem is model can fail silently. A silent failure is especially dangerous because nothing looks broken. The system keeps running, the output looks normal, and there is no warning message. But internally, the model is making a wrong decision without anyone noticing immediately. When a model fails silently, we still trust it. That is risky. Now, let's see accuracy. This is very common metric. Accuracy is usually first number people check when they evaluate a model. Accuracy tells how many predictions were correct. It simply counts how many times model prediction matches the actual outcome. Here it's like 90% accuracy. Accuracy looks good, but it hides important information. Accuracy does not tell us the model is uncertain or where it might fail or how risky its mistake could be. This misinformation becomes important in real world system. For example, imagine a medical diagnose model. I'm using medical to understand very critical real world example. A single wrong prediction can have a serious impact on person's health treatment. Like prediction is of like a person has a disease or not. And see, my model is giving the high accuracy, let's say 95%. This sounds very good on the model on paper basis. For one patient, if the model says no disease with very high confidence, the key point here is not just prediction but the confidence. Model is very sure about its answer, which makes the decision feel trustworthy. If model is wrong here, the cost is very high. A wrong prediction in this case could delay the treatment, cause harm, or create a false reassurance. The impact of single mistake can be much larger than accuracy number suggest. This is why accuracy is not enough. We also need to understand how confident the model is and whether that confidence can actually be trusted in critical situation. Accuracy is not equal to safety. Not at all. Like 95% most people would immediately assume that model is safe and use it without an hesitation. Let's talk about reliability. Reliability in machine learning is about trust. Reliability focuses on whether a model behaves in a way that aligns it with our expectations, especially when decisions matter. It goes beyond just being correct. A reliable model knows when it is confident and when it is not. Instead of acting sure all the time, a reliable model reflects uncertainty when the situation is unclear or unfamiliar. If models say 90% confident, it should be right about 90% of the time. This alignment between confidence and actual correctness is what makes the confidence meaningful and useful. Reliability checks whether confidence is meaningful. Without this check, confidence becomes just a number with no real world value. Like nothing. No, we can't trust model in the real world. So why model becomes unreliable? Overconfidence. One reason is overconfidence. That happens when a model reports very high confidence even in situation where it has little experience or understanding. The model feels very sure even when it should not be. This creates a false sense of security for users who rely on the model. Another reason is unfamiliar data. The real world is often different from training data. But models are forced to give the answers. Most models are designed to produce an output even when they are uncertain or confused. Reliable AI means building a system that we can trust. It includes understanding of uncertainty and correcting confidence. These ideas help model to express how sure they are in more honest way. It also includes robustness, monitoring. Model must continue to behave reliable even after they are deployed or used over time. Reliability is not optional in real system. When model affect people's life, reliability becomes an ethical engineering responsibility. Accuracy tells like how often model is correct and gives the partial or like general idea of performance, but it does not tell the full story. But reliability tells us when we should trust the model, or trust becomes critical when decisions have high impact or high risk. Better ML engineer need to have understanding on the reliability part. It helps you to design systems that are safer, more responsible and more realistic about their limits. Thank you.